Hi, welcome to this lesson where we'll talk more about rational expressions. So what is a rational expression and how can one be simplified? So in this lesson we're going to define rational expression and we're going to discuss different ways to simplify it. So a rational expression, again just to review, is an expression with a polynomial in the numerator and a polynomial in the denominator. So if you see in our example right here, the polynomial in the numerator is x squared plus 5, and in the denominator is x plus 2. It is a ratio of two polynomials. Alright, so now we know what a rational expression is. Let's talk about simplifying. First, we need to make sure that both polynomials, or both the numerator and the denominator, are completely factored. So if we look at our example of 10x squared times y over 15x to the fifth times y squared, we're going to break that down into as many prime factors as possible. So factors of 10, 2 times 5, they're both prime numbers. You can't factor that any more than it's already been factored. X squared can be factored into x times x, and y is just y. And in the numerator, 3 times 5, they're both prime numbers. We can't factor them anymore. And then you're going to have, since you have x to the fifth, you're going to have 5x's multiplied. X, and y squared is y times y. From there, we're going to take like factors in the numerator and the denominator, just like if I had, for example, if I had 6 over 4, I would factor these two numbers, 3 times 2 over 2 times 2, and I could simplify that to 3 halves because I have like factors in the numerator and the denominator, and the like factors is 2. So 2 divided by 2 is 1, so really I have 3 halves times 1, anything multiplied 1 is itself, so my answer could be reduced from 6/4 and simplified to 3 halves. So that's what's going over here, but at a much bigger scale. So I'm going to take all the like factors, 5 and 5, x and x, x and another x, oh no, sorry, x and x, yes, y, and then one of the y's, and then I need to identify what I have left in the numerator. In the numerator, I have a 2. I'm going to circle them. I like to circle them. It helps me stay organized. So I take that, and that's all I have left. In the numerator, I have 2. So everything here cancels out. When we say cancel out, what's really happening mathematically is that anything divided by itself is 1. So if I have two like factors, whatever they are, x over x, no matter what x is, anything divided by itself is 1, so we're just reducing that to 1. So I got a bunch of 1's here, and anything times 1 is itself, and 1 times 1 times 1 times 1 is 1. So that's why we can reduce fractions that way. So now I need to find what's left in the denominator, 3, and then x, and then a y. X times x times x is x cubed, so 3x cubed times y is my denominator. So we did that with numbers and variables. Now we're going to do that with polynomials. So in the example below, 2x plus 8, we need to factor that. How can we factor? Well, let's try to think back to when we were factoring polynomials. We can start with the greatest common factor, known as a GCF. There was the difference of squares rule. There was the perfect square. So for this problem, all we need to do is see that there are common factors in 2x and 8 in the numerator. So I'm going to take out the greatest common factor, which is 2, and I'm left with 2 times x plus 4. I'm going to divide x plus 4 and x plus 4 and get 1. That leaves me with 2 over x minus 4. And so therefore I just simplified the rational expression 2x plus 8 divided by x minus 4 times x plus 4. And my answer was 2 divided by x minus 4. So when I look at a rational expression, I can say, all right, x plus 4, it's a common factor there with x plus 4 in the denominator. And so that's going to give me 1 divided by x minus 3. Now, what you should do every single time that you reduce is check to make sure your answers are the same. So substitute a random number in for x to make sure that this expression will give you the same value as this expression. So 7 plus 4, I get 11. 7 minus 3, 7 plus 4. I get 4 times 11. And if I take 11 divided by 11, that gives me 1. And 4 in the denominator, which means I'm left with 1/4. 1 over 11 minus 3, which is, or sorry, 7 minus 3, which is 4. 1 over 4, it works. The equation holds true. One thing you do have to make sure, though, is is looking for what's called excluded values. Whoops. Here we go. Let me write this up here. Excluded values. It's important to make sure that you set both terms in the denominator equal to 0. Because when you have a fraction, you cannot divide by 0. It is impossible. So the denominator cannot equal 0. And therefore, I have to make sure that both of these factors do not equal 0. So I have to find out where they do equal 0, and I can do that. So if x minus 3 was 0, that would make the whole thing 0. So what makes x minus 3 equal 0? That's when x is 3. If x plus 4 equals 0, that would make the whole denominator equal 0. So I have to find out, where does x plus 4 equal 0? And that's at -4. So those are my excluded values. And so when I write my final answer, my final simplified expression, I would say 1 over x minus 3. And it's obvious when you look at the simplified version to say, okay, x can't be 3. So I do a little semicolon, x does not equal, it's a little equals with a line through it. X does not equal 3. And x does not equal -4. Now it's important to include that because we want this problem here to be the same function or polynomial or equation or expression, whatever we're simplifying. We want it to be exactly the same as the one before, which means it has to have both excluded values. So it's important to find your excluded values before you simplify. So find your excluded values before you simplify. That's all I have for you for this lesson. Thanks so much for listening. Go ahead and try the homework assignment and reach out if you need any help.